We're looking at mean value theorem here, and that's specifically looking at an average rate of change between 2 points. So the mean value theorem, it's this long written thing, and I'll explain it kind of visually next, and that should help clarify a lot. But it says, let f be a continuous function over the closed interval ab, and differentiable over the open interval ab. That just means that the endpoints are defined for the function, but it doesn't need to be continuous, or it doesn't need to be derivable at the endpoints. There exists at least one point C in AB such that the derivative of the function at point C is equal to f of b minus f of a over b minus a. In other words, there's at least one point on the interval where the derivative is equal to the average slope, or the average rate of change. Because that's what this defines. F of b minus f of a over b minus a just defines the average rate of change between those 2 points. So let's take a look at it. The mean value theorem, here's a depiction. So we've got f of a, we've got f of b, we've got a, we've got b. And you can see this dotted line in the middle is the average rate of change between those 2 points. Anytime we've got a function that is continuous and differentiable at all points, meaning it's smooth and it's continuous and connects these points, there has to be at least one point where the slope of that secant line, or of that connecting line, sorry, slope of that tangent line is equal to the average slope. And this is because if you start out with too low of a slope or too shallow of a slope, eventually you'll need to have a faster slope to get caught up and back at your point. And that means at some point, if it's going to be differentiable at all places, it has to pass through all of those options, all of those intermediate slopes. And at some point, it's going to have equal slope. So if it starts out with less slope, ends with more slope, somewhere in the middle it has to have same slope. Same thing if we start off too steep, too much slope, and then come down to too little slope. At some point in the middle, we have to pass through. And you could have something crazy where you've got lots of stuff, and then you have a bunch of them. But we know that there always has to be at least one, because either you go at the exact middle slope, and then all points have f of c equals, f prime of c equals the average slope, or you start out too shallow, or you start out too steep, or somewhere in the middle you switch between too shallow to too steep. But every time you go one or the other, you have to always kind of correct back and overcorrect past the original slope, or past the average slope. This is mostly a theory that's useful to identify that something does exist, but it doesn't ever tell you anything about where that point should be, or anything beyond just that there is a point that does exist. There's also Rolle's theorem, which I'm mentioning just because you should be familiar with the name, but it's kind of, in my opinion, a bit of a silly theorem to have, at least to be studying in this class, because it's just the mean value theorem, but where f of b is equal to f of a. And so it's a specific case where it says that there's some place where f prime of c is equal to 0. Because if your two endpoints are at the same height or same output value, then you're going to have some places where the slope is 0 in between them. So just the special name for the average slope being 0. And that's the mean value theorem.